In this video, we're going to take a look at parallel and perpendicular lines in the coordinate plane. We've already talked about this in algebra. This is a good review of writing equations and the relationship between parallel and perpendicular lines. First thing we're going to do is we're going to take a look at this graph. We're going to ask ourselves, what do we notice? We notice that line A, our purple line, and line B, our red line, are parallel. I also notice that A, my purple line, is perpendicular to C, my orange line. It's also perpendicular, C is also perpendicular to line B. That's great. Let's review on how to write the equations for these lines. If we're writing equations in lines, we need equations for lines in slope-intercept form. We need two things, the slope and the y-intercept. So if I'm looking at A, I already see on the graph my y-intercept is 3, and my slope I can count as 1 up 1 over 2, or 1/2. So for A, I can say my equation is y equals 1/2 x plus 3. When I look at B, I can go down to the graph and I can see that I have a y-intercept of -2 and a slope again of 1/2. So when I write my equation, I have y equals 1/2 x minus 2. Say for C, I really can't tell what the slope is. On this one you probably could, but let's say for a second we can't. I know my y-intercept is -2, but it's hard for me to tell what my slope is. So let's pick another point. Let's say -2, 2. So for C, I'm going to start with 2 points, -2, 2, and my y-intercept, 0, -2. I need to find my slope. Remember, slope is our change in y over change in x. So that's going to give me 2 plus 2 over -2 minus 0. When I simplify that, I end up with 4 over -2, which is -2. So therefore, I know my equation for C is y equals -2x, and my y-intercept was -2. I also need my equation for line D. When I look at D, I know my y-intercept is 0, because it's going straight through the origin, and I can tell I have a slope of 2 because I'm going up 2 over 1. So I get the equation y equals 2x. So again, just a little bit of review for you on writing those equations given a graph. Those would be my 4 equations there. Remember, parallel lines, and I can tell that from here, parallel lines have the same slope. That should make sense. Their steepness, if they're never going to touch, their steepness has to be the same. So if I have equations for parallel lines, I know I need to have the same slope, but I need to have different y-intercepts. If they have the same y-intercept, then it's just the same line on top of itself. Perpendicular lines have opposite inverse slopes. When you multiply the slopes, you get -1. That's how you can tell if they're opposite inverse. Question 1. Line P sub 1 passes through 0, -3, and 1, 2. Line P sub 2 passes through 5, 4, and -4, -4. Line P sub 3 passes through -6, -1, and 3, 7. We didn't know which of these lines, if any, are parallel. Well, we don't have to figure out, we don't have to graph them and look at them. We don't have to do that much work. All we have to do is find the slope. So my slope of P sub 1 is, again, change in y over change in x. And that's going to give me 2 plus 3 over 1 minus 0. So I get a slope of 5 over -1. Sorry, this should be a 0, and this should be a +1. So I get a slope of 5. My slope for P sub 2, so that second set of points, I'm going to have change in y over change in x again. So I'm going to have 4 plus -4, 4 plus 4 over 5 plus 4, which gives me 8 over 9. Lastly, I need to find my slope for my third line, P sub 3, and I'm going to do 7 plus 1, change in y, over change in x, so that gives me 3 plus 6, which gives me 8 over 9. So what I found here, I have P sub 1 has a slope of 5, P sub 2 has a slope of 8/9, piece of 3 has a slope of 8/9, so I can say piece of 2 is parallel to piece of 3. And I can't say anything else as far as this question is concerned. You'll recall from algebra, point-slope form. Point-slope form is one of my forms of my equation. The other two is standard form and slope-intercept. Point-slope form says if I know my slope is m equals change in y over change in x, then the equation of the line is the cross products of this proportion. So I'm going to cross multiply and say that this y minus y sub 1 equals m times x minus x sub 1. It's an easy, quick way for us to get an equation if we have 2 points. Question 2 says write the equation for the line that is A, parallel, and B, perpendicular to this equation, y equals 2/5 x plus 3, and passes through negative 5, 0 in slope-intercept form. So I'm going to start with A. If I want to be parallel to this line, that means I have to have the same slope. So I'm going to use my point that I'm going through, negative 5, 0, and my slope of 2/5. Remember, they're parallel lines, so they have to have the same slope. Then I'm going to use my point-slope form. Point-slope form says I'm going to do y minus my y-coordinate is equal to my slope, 2/5, times x minus my x-coordinate, which would give me x plus 5. I want my final answer in slope-intercept form, so all I need to do is solve for y. This is easy. Y minus 0 is y, distribute 2/5, and there's my equation for the parallel line through point negative 5, 0. Part B asks for the perpendicular line. Well, remember, we said perpendicular slopes are opposite inverse. So while my slope of this one is 2/5, my perpendicular slope is going to be negative 5/2. And I'm still going to use the same point, negative 5, 0. I'm going to use my point-slope form again, especially since I'm solving for y. So that gets me y minus 0 is equal to negative 5/2 times x plus 5, and then solve for y. And I'm finished. Next question says, decide whether the lines are perpendicular and explain. My explanation is showing on paper that my slopes are opposite inverse. Well, how do I do that? I show that when I multiply my slopes, I get negative 1. So if I'm looking at my slopes, this one has a slope of negative 2/3. This one has a slope of negative 3/2. So I can already tell these are not perpendicular because this is not the opposite inverse of this. It's close, it's the inverse, but it's not the opposite inverse. So how do I prove it? I would say, okay, well, negative 2/3 times negative 3/2 is positive 1, not negative 1. So are these perpendicular? No, because the slopes are not opposite inverse. When I multiply them, I get positive 1 and not negative 1. 3a says line G has the equation y equals 3x minus 2. I want to find the equation of the line in point slope form H, so I'm just saying I'm naming my line H. That passes through 3, 4 and is perpendicular to G. So again, my perpendicular slope, if this slope is 3 and I want to be perpendicular to that, then I need to be opposite inverse. So that means I'm going to have a perpendicular slope of negative 1/3. And the problem says I'm going through the point 3, 4. So again, I'm going to use my point slope form, especially since I want my equation in point slope form. So I'm going to say H has the equation y minus 4 is equal to negative 1/3 times x minus 3. And that's my answer. There's no further work that I need to do for this one. 3b says, okay, write the equation parallel to g. So remember, parallel has the same slope, so I'm not going to change my slope of 3 at all. I'm going to use it as it is. So I'm going to use a slope of 3, and I'm going to use my point again. So I get y minus 4 is equal to 3 times x minus 3. And that would be my answer for my equation for h. Next problem says, the equation y equals 5/4 x minus 5/3 x minus 4 represents a mirror. A ray of light hits the mirror at 3:1. What is the equation of the line P that is perpendicular to the mirror at this point? In other words, I'm finding the equation for the line for my ray of light, because my ray of light is hitting that mirror in a perpendicular angle. So remember, if I'm talking about perpendicular, I need to take my original slope and I need to do opposite inverse. So that means my perpendicular slope would be -3 over 5. And I'm going to go through point 3:1. So I'm going to plug that into my point slope form again. So I get y minus 1 is equal to -3/5 times x minus 3. Then I'm going to distribute, so I get y minus 1 is equal to -3/5 x plus 9/5. Let's put this one in standard form, just for some good practice. Remember, standard form is when we have ax plus by, so x and y are on one side, and my constant term is on the other side, so ax plus by equals c. I don't want any fractions, so the first thing I'm going to do is multiply everybody by 5 so that I can get rid of that fraction. That's going to give me 5y minus 5 is equal to -3x plus 9. So remember, x's and y's on this side, constants on this side. So I'm going to add 3x to both sides. That's going to give me 5y plus 3x. And then I'm going to add 5 to the other side, which will give me 5y plus 3x equals 14. That would be my final answer.